Welcome everybody to your first video flip notes presentation for your chemistry year. Here we go. Ready? What is matter? Topic number 1. SWBAT. Students will be able to classify matter using specialized vocabulary that we're about to learn and be able to interpret particle diagrams. Here's some examples. This one is of a solid. Here's a particle diagram of a liquid and of a gas. They all have spheres of different colors, different things. They're arranged differently. This gives us information about the property that's different between solids, liquids, and gases. So let's learn how to do these things. Just to start, what is chemistry? Well, chemistry is the study of matter and energy, those two things. When we start talking about matter, we need to use certain notations. Notations being, how do I convey information? Here's some examples in our black box, right? I have a chemical formula. I have a picture. I have a symbol. All these things convey information to us. So we need to be able to not only take that information and use it, how do I create it so I can send that information to somebody else? Okay? So let's get into some definitions about what matter is. Okay, so first off, matter can exist in two things, physically separated or not. So first off, matter that cannot be separated by physical means, pure substance. Each piece looks the same. Each piece has the same composition. So think of your bag of Skittles. I open up a bag of Skittles and I got all yellow ones. Every Skittle in the bag is yellow. Can I separate things by color now? Nope, one big pile. Okay, now let's examine if we can separate by physical means. If I can separate by physical means, I'm a mixture. Each piece has different colors or shapes or something that's unique. So now I open up my bag of Skittles and I got all the colors of the rainbows. I can make a green pile and a yellow pile and somehow hide that red pile for my little brother or sister who just loves them, you know what I'm saying? But I was able to separate those things. So now I got two different kinds of matter, right? Pure substance and a mixture. All right, now we're going to take it cannot be separated by physical means and explore it just a little bit further. So if I cannot be separated by physical means, I can break that down into cannot be separated by chemical means. All right, so if I cannot be separated by chemical means, I am an element. An element is the simplest form of matter. An example of a monatomic element, one atom would be sodium Na, diatomic, two atoms, chlorine gas. Simple forms of matter, elements, cannot be broken down by chemical means. Now, certain forms that cannot be separated by physical means, but can be separated by chemical means, we call that a compound. A compound or a molecule, two different elements put in together. We see this all the time in everyday life. NaCl, table salt, H2O, water. These are the things we come into contact with a lot. We can break these things down by chemical means. We might even learn how to break some of those down. On the right-hand side, things that can be broken down by physical means, we can further classify. Same composition throughout. If I can have the same composition throughout, I'm homogeneous. Examples, salt water, iced tea. I can't see a difference in these things. So homo means same. Now, if I have a different composition throughout, I can see differences. That's heterogeneous. It's not uniform throughout. So think of Italian dressing. You see all the little particles inside. Concrete usually has big rocks and small little pebbles in it. Soil, chocolate chip cookies. Hetero means different. These red pieces in here that you see in the boxes, guys, these are what you need to be writing down in your notes. Now, particle diagram. A particle diagram of something that cannot be separated by chemical means. An element. This is a diatomic element. Notice the circles are the same color, same size. Diatomic element. Something that can be separated by chemical means. Compound. Here's water. You see that right here in this particular molecule, I have two different colors, two different sizes. I have a big red and small whites. That represents different atoms, so that makes it a compound. I can separate these by chemical means. Now on back onto the other side, under can be separated by physical means, but same throughout. Here we go. So it's the same throughout. I have an element here that's blue and an element here that's white. I can separate these by physical means depending on the characteristics, but it's uniform throughout. Okay? If I get over to something that's heterogeneous, now I got different stuff. I can of course separate these by chemical means, but it's not the same all the way throughout. Each thing has different things in it. So here I got oxygen and hydrogen. Here I have nitrogen and hydrogen. Here I have carbon. So different things that can be separated through chemical means, heterogeneous. So that's what we're going to see in our diagrams. Here's an example problem. Which particle diagram represents a mixture? Well, mixture. Go back to that thing that we just did. Mixture, is it uniform all the way throughout? No. So, all right, let's look at number 3 first, just because I'm right here. I see white dots. Anything different? Nope, same all the way throughout. Moving over to number 1, I see a black and a white dot, but everything's got a black and a white dot. So everything here, uniform. Okay, not a mixture. Moving on to 4, I see diatomic, black dots. Everything's the same all the way throughout. That's not a mixture. Oh, number 2, oh, I have a white dot and I have a black dot, and they're not bonded. They're all scattered out. This is a mixture. Two different things together. Here we go. That's a good start to your examples, right? So now you should be able to draw and interpret particle diagrams. You should be able to draw elements. You should be able to draw compounds. You should be able to draw mixtures. You need to understand key vocabulary terms. You may have to look this up in your book if you take it home. Check it out on the internet. Element, compound, mixture, homogeneous, heterogeneous. Homo is the same, heterogeneous is not. So now we should be able to explain the different kinds of matter that there are. That's the end of your notes packet, guys. For tonight, I need you to continue on with your example problems and use what we learned to finish them up.